Okay. Hi, my name is Jiří Benz. I'm from Red Hat, and I'm going to talk about namespaces and Open vSwitch. Everybody wants namespaces nowadays. It's the base for containers, so it's Docker, Kubernetes. It's also used heavily by OpenStack. And for those of you who do not know what namespaces are, the namespaces are a way to partition networking stack. It has basically nothing to do with names, or not much to do with names. It's really about resource isolation, so you can have different networking interfaces in different parts of the stack that don't see each other, so on. OVS does support namespaces somehow. I would argue that the support is not complete. There are some strange results if you try to use that we actually see each day with OpenStack. So what we can do, we can take an interface that's in an OVS bridge and move it to a different namespace. That works. That's the first example there. What we cannot do is to take interface that is already in another namespace and put it into an OVS bridge. So, yeah. If we have situation like after the first example, and we try to look at the statistics of the interfaces and so on using OVS tools, we see very weird results, like not seeing the interface or seeing statistics for wrong interface and so on. I will cover that later. Let's start with the kernel. This is obviously a feature of the kernel data path. So let's start with the kernel. The kernel provides the means to isolate packets that are crossing namespaces by the means of calling the kernel function skb scrap packet. This was called for this function was actually recently added to the OVS code. Thanks, Joe. I don't know what to. Thanks. So it's nice first step. Let's see how it's done. It's in OVS vport receive. So when the packet is received, its namespace, namespace of the interface it was received through, is compared to the data path network namespace. What's the data path network namespace? That's the question. It's basically the data path that the socket that created that's the namespace the socket that created the data path was in. So basically, it's the data path of OVS vSwitch-D. So let's assume we have example like that. We have two namespaces, OVS vSwitch-D and OVS DB server is one of them, and we have a couple of interfaces in other namespace. If we send a packet or receive a packet through ETH1 and we switch it to ETH0, then yeah, sure. ETH1 is netns0, data path interface is root namespace, everything works, packet is scrapped, and it's OK. Let's look at the opposite direction. Now we received packet from ETH0, compare it to root namespace where the OVS vSwitch-D is there. Those are the same, so we don't scrap the packet. And we send it to a different namespace, which obviously is not a good thing to do. So we're missing something here. Let's look at this example. We switch between interfaces ETH1 and ETH2. They are both in namespace 0, but this is a different namespace than root namespace. So we're scrubbing the packet, although we should not have to. So the obvious solution to this is to compare the incoming and outgoing interface to see whether they are the same or whether they differ, and act accordingly. Obviously, we do not know about the outgoing interface until we're sending the packet. So the only point where to do that is OVS vport send function, where we can actually do that. I think we have both information ready at that point. So that seems pretty easy to do. Is it? So what about tunnels? Actually, tunnels, when I started to think about this many months ago, tunnels were quite a nightmare because they were handled special way, and to think about where to scrub the packet and in which condition, that was pretty hard. Now, thanks to Thomas Graf, thanks, I don't think he's here, it's pretty easy because we have lightweight tunnels. Tunneling interfaces is just another net device, so nothing special here. This is solved. But we have another thing that's pretty new, and it's Contract. So what about Contract? Contract, I mean the matching of the connections, that's per namespace. Currently, the contract is performed in the data path namespace all the time, always. So if we move this SKB scrubbing to the vport send, that's too late because it may happen that we receive a packet through some namespace and we want to do contract in the data path namespace, which is a different one. So we need to scrub the packet. The question is where to do that. Let's look at the last example again. We're sending packets between the two interfaces that are in the same namespace, but that's a different namespace than the OVS vSwitch D1. So obviously in this packet, one would say, well, the right namespace to do contracting here is netns0 because we're moving packets only in that interface. So yeah, why shouldn't we actually change that to not doing contract in the data path namespace, but doing in the namespace that we're, let's say, received the packet in? This breaks in this case. If we did it in the namespace where we received the packet, that would mean that if we're sending packets from netns1 to netns2, we're doing contract in netns1, and we're responding. We're doing contract in netns2, and we never match. So that's a problem, and I admit I don't know the solution to this. If anyone does, let me know. User space. So we have also problems in the user space, not just in the kernel. The most obvious problem is that OVSDB contains just the interface name as a string, as a text. There's no notion of namespaces. There is nothing about namespace. So, and also the fact that it contains just the interface names brings problems on its own. So I have a nice example at the bottom. We add ETH0 port to or interface to a bridge. Then we rename it to something other. And then we take ETH1 and rename it to ETH0. Now what happens? The kernel data path is aware of what we did because it just gives pointers in the memory. So it has pointer to now shadow 0 net device. But the OVSDB still contains ETH0. So if we run OVS, for example, OVS OFCTL show, we get statistics for wrong interface or data about wrong interface, about ETH0 that's right now. While OVS DPCTL show will show us shadow 0 connected to ETH0, connected to BR0. By the way, that's even worse with the current master of OVS because both shadow 0 and ETH0 will be there because there's some logic to watch netlink and to see whether interfaces are added, yeah, that are in OVSDB. So this is probably broken. Obviously, with names, we can do a similar thing with namespaces. I can create a new namespace, move an interface to that namespace now, and it just disappears from the current namespace. So if I run OVS OFCTL, OVS VSCTL, and so on, it tries to find the ETH0 interface, but it's not there anymore. Bad luck. How to fix that? So we could listen for netlink events. We actually already do this, so we can listen to netlink events and updating the OVS DB accordingly. So when an interface is renamed, we update the OVS DB to contain the new name. I think that should work mostly. One thing that's not clear, at least not to me, what to do when an interface is deleted from the kernel, because we probably don't want to delete it from the OVS DB, or maybe we do. I don't know. But it's good to know that it has other problem. And that is the fact that the kernel reports moving of one interface to of an interface to another namespace as if the interface was deleted in the old namespace and it appeared in the new one. That means that we have really no way, no reliable way, to find out that this is actually interface that was moved, and not that somebody deleted the old interface and created a new one. We're obviously lacking something here. We're missing API, the kernel, that would allow us to track this. So that's the problem. Other problem that we have is that we need to be listening in all namespaces, because if the interface disappears in one namespace and appears in another one, we have to listen in that target namespace to learn about this. Up to, I don't know which kernel, up to recently, this meant that we would have to keep open netlink socket in each namespace. We don't have to do that anymore because of Nicholas Dichtel, who merged a patch set that allows to set socket netlink listen all NSID, which allows us to listen in all namespaces. Well, almost in all namespaces, because we can listen only in those namespaces that have NSID assigned, which is not automatic. That's something that has to be triggered somehow. There's an API for that, so if we can trigger that from the user space, or it can be triggered implicitly on certain netlink DAM operations. But the point is that newly created namespace doesn't have NSID assigned. So this option actually won't help us. Again, we're missing something here. We're missing an API in the kernel that would allow us to listen for new namespaces. Let's say that this is solved. Yeah, we implemented those two things somehow, which, by the way, is not so easy because we have that nice features called checkpoint and restore in user space, which actually prevents us from having any identifier that is stable and not settable and unique and so on. So go figure out. Let's assume that we solved that somehow, and now we can listen to those events and reliably match those things and so on. We still need to store that information somehow. So the obvious thing is storing netNSID in the OVS DB, probably. It's an integer that's easy to store, so why not? One thing to know about netNSID is that this number, this identifier, is valid only in the namespace that it was created for, meaning netNSID is a way to reference other namespaces from one particular namespace. And from other namespace, those netNSIDs will be different. But yeah, it's probably quite I would say logical to have those NetNS IDs from the OVS DB server namespace. So yeah, why not? Because we cannot, the problem we have with this is that we cannot use a NetNS ID to switch to that namespace. We can use file descriptors through that, but we don't have, obviously, file descriptor, or we cannot have file descriptor in OVS DB. Again, we're missing something. We're missing an API that would allow us to switch to namespace using NetNS ID. Why we need that? We need that to fetch statistics from the interface and other stuff to do with the interface, because unless we switch to that namespace, we don't see that interface. It's not all. We have still some problems with that. Even if we implemented the syscall or something that would allow us to switch to a namespace using NetNS ID, we still have a problem. So let's assume a situation like this. OVS vSwitchD and OVS DB server is running in a namespace, but we're communicating with this from a different namespace. So OVS VSCTL is run from a different namespace. So we read the data from OVS DB server. In particular, we read the NetNS ID this is the pointer from root NetNS to NetNS1. And we send it to OVS VCTL. But obviously, as I said, this number means nothing in NetNS0. So we cannot use it to really look into the interface and so on. So yeah, another problem to solve. So that's basically what I was thinking about in past few months. And as you probably see, it's not an easy problem to solve. Everybody wants that, but nobody knows how to solve that, as is so far. If you have any ideas, I'm all yours.
All right, let's And we now have time for questions. I'm going to preempt one of them by, if you go back to your previous slide, the very last one, then I think there may not be as much of a problem here as you expect, because OVS OFCTL, OVS VSCTL, and OVS DB server never do anything with networking, except
I think isn't it OVS DB server actually who does fetch the statistics and stuff like that? Because
no, it is only a database. It has no knowledge of network devices or anything like that. So I think that particular problem may not be as much as you expect.
I think I think I look into that, and I saw problem with, especially with interface statistics, which are written by, but whatever.
vSwitchD gets the statistics, but if it gets pulled into a compatible namespace, then it doesn't see anything.
But the other problems, I agree. Yes. Okay. So whoever was first, please.
Very quick one. So if you use VATH pair and just forget the optimization, do you still have problem? You report the problem to the management, but will it fly from a NetNS perspective? Because with VATH, the only crossing point between NetNS would be the VATH.
Yes.
So it would work, right?
Yes, VATH is okay, and that's actually a reason why in OpenShift we're using VATH to cross namespaces.
Joe?
So first of all, thanks for putting this together, because there's a lot of thoughts there, and I think this discussion will continue to occur. I don't know if you've thought about the case where you have multiple instances of OVS running, so you have a data path in one namespace and a whole nother data path in another data namespace. Say if you want to run OVS inside of a container for some reason. There's a whole nother sort of layer of issues like that. Yeah.
Yeah, and I didn't even mention process namespaces, because network namespaces are per process namespace. So. Yeah.
Yeah. To follow up on this, I think it would be nice from my perspective to have a single OVSDB to rule them all. That would be nice. What I currently have to do whenever I put OVS in a namespace is I have to create another OVSDB. And that actually works fine. And in fact, that's the common use case of containers, where your container is sort of like, for a heavyweight container where you're really kind of running the operating system, you want to run your own OVSDB and stuff like that. For something like Mininet, where I'm creating hundreds of switches, well, it's maybe not non-optimal to have 100 different OVSDBs, even though they're really small. I mean, the overall amount of state is the same, whether it's all dumped into one basket. And actually, it's faster to have multiple OVSDBs, because that way each one is smaller, and each time you do transactions on it, you have to read less state. So it's actually kind of nice in a way. But be that as it may, I still would like to have one OVSDB to rule them all that was namespace aware. That would definitely be nice. Regarding the sort of monitoring namespaces, can't you just monitor procfs to see when they're created? And if
They don't necessarily have a name in the file
Sorry.
system unless something's put
I probably didn't get the question. So, what do you
I guess
mean?
my point being that usually when you create a when a process creates a namespace, it gets I guess its state actually that namespace is visible in the procfs file system.
It doesn't have to.
And it's different.
It doesn't have to. It's only if there are. You're right that
there are two ways of creating it, as I understand it. One is to create it in the file system, and one is to create it an anonymous one in the process that's anchored to the process, and both of those show up in procfs, if I'm not mistaken.
You can have a namespace mounted somewhere, and you actually can have no process in that namespace running. Procfs only shows the namespaces each process runs in a namespace. So these processes are available.
I guess the
in
point being
process
that if you can view a process's procfs, you should also be able to see all of its namespaces.
No.
No?
No.
Really? So how do you create how do you create an anonymous namespace that exists neither in procfs and also doesn't have an anchor process?
So
well, we can chat. We can chat offline, but
Yeah.
I've never seen that done.
okay,
I guess.
try ipnetns command, just run it, create namespace. You get a new namespace that has no process running inside.
Yes,
as
yes,
simple
but
as
it's still
that.
visible in procfs.
It's not.
It is.
Where?
It is because otherwise IPNetNS list wouldn't do it. Wouldn't show anything.
Because it's mounted in a well-known location in /var.
Yes,
That's
my point.
Yeah, but it's not procfs.
It's still oh well okay. procfs / I mean it's visible in the virtual file system. I guess is my point.
Have you thought at all about nested network namespaces? they work mostly, but
Yeah, no, not really. I mean, sorry, I previously said process namespaces. I meant user namespaces. So I think even with user namespaces, it's even much more complicated because
Right.
I think NSID and stuff like that doesn't work across user namespaces.
Right.
So that's even worse. So no,
Okay.
no idea no idea how to solve situations like that.
I've actually had a lot of good experience. Well, I to try to once I managed to run Mininet self-hosted, I wanted to see how many levels down I could do it, and I did it up to like 7 levels, and before I got bored or tired. And the beautiful thing about namespaces is things don't slow down much at all. It's wonderful. You can do a lot of nested virtualization. So it's a really interesting thing. It's not particularly practical, but it does seem to work. And I was pleased that Open vSwitch over time evolved to actually where this worked. Originally, it didn't work at all, but now it seems to work fine.
So if it's okay, I'd like to suggest a couple principles that we might want to consider while we're figuring out how namespaces should be handled. One is that I think that it should still continue to work okay if OVS isn't, it should still continue to work the same way if OVS isn't running. So some of these things that you suggested, like noticing when interfaces move from one namespace to another, I worry that that'll only work if OVS is running and notices at the time, and that if it starts up again afterward, after it's happened,
Yep.
then there's no way for it to notice. So OVS, its database generally contains it contains state, not events. And so it's meant, or excuse me, it's meant to have the same effect regardless of how you got there. And so it shouldn't make a difference, basically, what's going on, but only what's on the system. So it would be nice to maintain that property if we can. Well, let's talk about it. But you bring up a lot of real issues, and it's stuff that we definitely need to do better on. So thank you very much for the presentation. Let's thank our speaker one more time.